So as promised, this is the wrap up to 8.4, and these are properties of convergent series, and these properties look very, very similar to what we saw with sequences, which go back to the properties that looked familiar to us from our limit laws. So the thing that I want you to realize with these laws is that these laws hold for positive terms. So all the AKs have to be greater than 0. If that's the case, if you multiply a series, the first one says if you multiply the series by a constant, then you can multiply the convergent value by the constant. So that's pretty straightforward with that falls in line with limits. The other is if you've got a convergent series A and it converges to the value of A, and the sum of the BKs converges to B, then if you look at the series with each of the AK and BK terms together subtracted or added, then your results are going to be added or subtracted. And again, this follows directly from the limit laws. Whether a series converges, and this is probably the most important one that you may not realize, whether a series converges does not depend on a finite number of terms added or removed. So here you have your infinite series AK going from k equals 1 to infinity. If I drop a few terms, started at m, it's still going to converge or diverge based off of going from 1 to infinity. So, removing or adding a few terms doesn't change the convergence or divergence of a series. It would change the value if we could find it, of course, but there's only a handful of series that we can actually find the value of. So that's it for the limit laws, or the properties of convergent series. What I do want to do is one simple example for you. I'm going to pause here. Okay, here's the example that I want to use to demonstrate the properties of convergent series. And you've got an infinite series of a difference. And if you notice that this series, and this series, they're both geometrics. Right? They're both geometrics, and hopefully by now, after some practice with the geometric series, you can identify them pretty quickly. But expand out the first few terms, or just recognize this is A, R to the K, right? So A is equal to 3, and R is equal to 2/5 in the first series. The second series, A is equal to 2, and R is equal to 5/7. So by the definition of geometric series, this one is going to converge to A over 1 minus R, which is simply 3 over 1 minus 2/5, which is equal to 5. This is going to converge to 2, and you know what, I'm going to put the negative sign in here. No, I'll leave it all. 2 over 1 minus 5/7, and that's going to converge to 7. So, using the convergence, the properties of convergent series, and the one we're using is number 2. So, the sum of the AKs minus BK is equal to the sum, is just simply equal to A minus B. Here's A, here's B. So 5 minus 7 equals negative 2. And that's your answer, using the properties of convergent series.